Hello students, welcome to SOURAV sir's classes. The question is, applicants for the doctoral programs of Ambi Institute of Engineering and Bambi Institute of Engineering have to appear for a common entrance test CET. The test has 3 sections: physics, chemistry and maths. Among those appearing for CET, those at or above the 80th percentile in at least 2 sections and at or above the 90th percentile overall are selected for Advanced Entrance Test AET conducted by AIE. AET is used by AIE for final selection. For the 200 candidates who are at or above the 90th percentile overall based on CET, the following are known about their performance in CET. No one is below the 80th percentile in all 3 sections. Statement 2. 150 are at or above the 80th percentile in exactly 2 sections. Statement 3. The number of candidates at or above the 80th percentile only in P is the same as the number of candidates at or above the 80th percentile only in C, the same as the number of candidates at or above the 80th percentile only in M. And statement 4, number of candidates below 80th percentile in P, number of candidates below 80th percentile in C, number of candidates below 80th percentile in M is equal to 4:2:1. BIE uses a different process for selection. If any candidate is appearing in the AET by AIE, BIE considers the AET score for final selection provided the candidate is at or above the 80th percentile in P, that is physics. Any other candidate at or above the 80th percentile in P in CET but who is not eligible for the AET is required to appear in a separate test to be conducted by BIE for being considered for final selection. Altogether, there are 400 candidates this year who are at or above the 80th percentile in P. What best can be concluded about the number of candidates sitting for the separate test for BIE who were at or above the 90th percentile overall in CET? So let us represent the 3 subjects by a Venn diagram. This is physics, this is chemistry, and this is maths. Let this be A, that is students only in physics, D, both in physics chemistry, B, only in chemistry, E, physics and maths, G, in all 3 physics, chemistry, maths, in chemistry and maths F, and only maths C, and in none H. Now from statement 1, no one is below the 80th percentile in all 3 sections, so H is equal to 0. From statement 2, 150 are at or above the 80th percentile in exactly 2 sections, so D plus E plus F is equal to 150. From statement 3, the number of candidates at or above the 80th percentile only in P is the same as number of candidates in C and M. So from statement 3, A is equal to B is equal to C. Since there are a total of 200 candidates, 3A plus G is equal to 200 minus 150 is equal to 50. From statement 4, 2A plus F is to 2A plus E is to 2a plus d is equal to 4 is to 2 is to 1. Therefore, 6a plus d plus e plus f is rather divisible by 4 plus 2 plus 1. So this is divisible by 4 plus 2 plus 1 equals 7. Now since d plus e plus f is 150, so 6a plus 150 is divisible by 7. That is 6a plus 3 is divisible by 7. Hence, a is equal to 3, 10, 17 and so on. Further, since 3a plus g is equal to 50, a must be less than 17. Therefore, only two cases are possible for the value of a, that is a is equal to 3 or 10. We can calculate the values of the other variables for the two cases. So a is equal to 3 or 10, then d is equal to 18 or 10, e is equal to 42 or 40, f is equal to 90 or 100, and g is equal to 41 or 20. Among the candidates who are at or above the 90th percentile, the candidates who are at or above the 80th percentile in at least two sections are selected by AET. Hence, the candidates represented by D, E, F and G are selected for AET. BIE will consider the candidates who are appearing for AET and are at or above 80th percentile in P. Hence, BIE will consider the candidates represented by D, E and G, which can be 104 or 180. So 104 or 80. BIE will conduct a separate test for the other students who are at or above 80th percentile in P. Given that there are a total of 400 candidates at or above 80th percentile in P, and since there are 104 or 80 candidates at or above 80th percentile in P and or at or above 90th percentile overall, there must be 296 or 320 candidates at or above the 80th percentile in P who scored less than 90th percentile overall. The number of candidates sitting for separate tests for BIE who were at or above 90th percentile in CET is either 3 or 10, that is option A. The next question, which is a continuation of the previous one, is if the number of candidates who are at or above the 90th percentile overall and also at or above the 80th percentile in all three sections in CET is actually a multiple of 5, what is the number of candidates who are at or above the 90th percentile overall and at or above the 80th percentile in both P and M in CET? Now since G is a multiple of 5, G equals 20, so number of candidates at or above 90th percentile overall and at or above 80th percentile in both P and M is equal to E plus G, that is 60, so option A. If the number of next question, if the number of candidates who are at or above the 90th percentile overall and also at or above the 80th percentile in all three sections in CET is actually a multiple of 5, then how many candidates were shortlisted for the AET for AIE? So since G is multiple of 5, G equals 20, and number of shortlisted candidates for AET is D plus E plus F plus G. So 10 plus 40 plus 100 plus 20 equals 170. It is option A. The next question is, if the number of candidates who are at or above the 90th percentile overall and also are at above the 80th percentile in P in CET is more than 100, how many candidates had to sit for the separate test for BIE? So, number of candidates at or above the 90th percentile in overall and at or above 80th percentile in P in CET is equal to 104. Therefore, number of candidates who need to sit for a separate test is equal to 296 plus 3 equals 299. So option A.